It is finally trig time. I'm so excited to finally get started on the trigonometry part of this class. It's my favorite. So we're going to start off with right triangle trigonometry, which is something that may feel a little bit familiar from your geometry classes. Okay, so right triangle definitions of trigonometric functions. There's two different ways we can think about a right triangle. On a circle, and in trigonometry, what you're going to see is different. In geometry, you focused on triangles, which have a total measure of 180 degrees. But what if we want to be able to use angles that are bigger than 180 degrees? We have to move to a circle for that. And that's a lot of what we spend our time doing in trigonometry. So on the circle, we have our radius, which ends up being the hypotenuse of our triangle. And then if you drop vertically down and horizontally across, that's where we get our right angle. Okay, so that's at any point on the circle. If my radius went to here, then my right triangle would be right there. We'll get into that in more details. But remember the way that we look at the sides of the triangle. If theta, this is the Greek symbol, it's the lowercase level theta, and it does have a TH, not an F. Theta is cheese. Theta is an angle. So the angle theta, if you look directly across from theta, that's going to be the length of the side opposite of the angle. The hypotenuse is always across from the right angle, and so the only side left is the adjacent side. So that's how we're going to name the sides of the triangle. Another thing I want you to notice is that when we name the angles, capital A, capital B, capital C, then the sides get named the lowercase version opposite that. So opposite B is little b. So that's always how we name triangles. Now, you learned 3 trigonometric functions for right triangles in geometry. You learned sine, cosine, and tangent. And remember that what you learned, probably to help you remember that, is so, ka, toa. And I think it's helpful to write it that way because what that helps you remember is that the sine is equal to opposite over hypotenuse, that's so. The cosine is equal to adjacent over hypotenuse, that's ka. And the tangent of theta is equal to the opposite over the adjacent. Okay, now tangent is a function, so is sine, so is cosine, so is anything. Just like when we write f of x, for example, you're plugging x into the function f. So when we do the tangent of theta, we don't have to write parentheses there, but it's the same kind of idea. You plug an angle into a trig function, okay? That's what the domain is angle measure. So that's what we can plug in. Okay, now, each of these other 3, and these are the ones you probably have not learned yet, these are the reciprocal functions. Reciprocals, okay? The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Remember, reciprocal just means flip it over. Now, how do you remember which ones go together? Well, tangent and cotangent, that's pretty easy. How do you pair up the secants? Well, no two cos can go together. So if I'm using sine, the reciprocal is cosecant. And if I'm using cosine, the reciprocal is just secant. Okay? And that's what these abbreviations stand for. These are all words, okay? These are abbreviations for the words. This is the sine, this is the cosine, and this is the tangent, okay? I don't want to hear anybody tell me about the tan of a number. That's not the word. That's the abbreviation for the word tangent. So we need to use the words, not the abbreviation. CSC is the abbreviation for cosecant. Whoops. SEC is the abbreviation for secant, and COT is not cot. That's the abbreviation for cotangent. If you say tan or cot or sin or cos to me, I will correct you. Don't take it personally, but we need to make sure we say it correctly. Okay, so if the sine, so, is opposite over hypotenuse, SOH, then the cosecant is hypotenuse over opposite because they are reciprocals, okay? So in the triangle below, triangle ABC, we want to find the value of each of the 6 trig functions of theta. So again, let's look at where theta is. Theta is right here, so it's angle A. So that makes this side the opposite because it's across. The hypotenuse is always across from the right angle, so the only one that is left is the adjacent. That's kind of hard to see. Let me move that. This side is the adjacent side. Okay, so we're going to remember SOHCAHTOA. We're always going to start with sine of theta. You have to have something inside it. You can't just write sine. That would be like writing this. You can't leave it blank. You have to put something in there. And the angle is always what goes inside. So we're going to have sine of theta, cosine of theta, and tangent of theta. Sine is opposite over hypotenuse. So the opposite is A. The hypotenuse is C. We don't actually know what C is, but remember, we can use the Pythagorean theorem and say 5 squared plus 12 squared equals C squared. Now, you may recognize this one as a Pythagorean triple. When you solve, you're going to get C equals 13. So that's the value for C. We don't want to leave it unknown when we can figure it out. So sine of theta is opposite, which is 5, over hypotenuse, which is 13. So the sine of theta is equal to 5/13. That's the answer. That's it. We're just putting the pieces together in the right spot. Cosine, cosine equals adjacent over hypotenuse. The adjacent is 12. The hypotenuse is 13. And tangent, TOA, is opposite over adjacent. So opposite is 5 and adjacent is 12. We're halfway there. Once we have those, now we need to do the reciprocals. So the reciprocal of sine is cosecant, and reciprocal means flip it over, 13 over 5. You don't even have to do anything. We've already got the numbers. We just need to reverse it. The reciprocal of cosine is secant, so that's going to be 13 over 12. And the reciprocal of tangent is cotangent, so that's going to be 12 over 5. And that's it. That's the value of each of the 6 trig functions. So notice what sine, cosine, tangent, cosecant, secant, and cotangent represent. They represent a ratio between the sides of the triangle. So you can put 5/13 in your calculator and you get 5 divided by 13, you get 0.385. So the sine of theta is equal to 0.385. That number represents the ratio between the opposite side and the hypotenuse side. That's how these work. Okay. Go ahead and pause the video and try number 2. Now, you are going to have to solve for B, and you are going to get a radical. Leave it as a radical, not as a decimal. So let's start by solving for B before you get too far. Go ahead and do that really quickly. So when we solve for B, you should get 1 squared plus B squared equals 3 squared. So this is 1 and this is 9, so B squared is equal to 8. And when you square root both sides, we don't need a plus or minus because the triangle can't have a negative side, but we do get 2 root 2. Okay, so that's what we're going to use for B. Now pause your video and go ahead and try finding all 6 trig functions. I'll be back in 3. before you get too far, remember that we need to rationalize the denominator. I know I told you in calculus we don't do this, but we're not there yet. So you have to rationalize the denominator. Since we have the square root of 2 in the denominator, that's what we want to multiply by. And so on the top, we get the square root of 2, but down here we get 2 times 2, because that's the square root of 2 times the square root of 2. So 2 times 2 is 4. So make sure that you rationalize all the rest. You can pause the video and make sure you've done that correctly before I put up the rest of the answers. I also made a mistake that I need to correct. I don't know what I was doing. I put the wrong fractions together. So sine is opposite over hypotenuse. So the sine would be 1/3. Cosine is adjacent over hypotenuse. So that's 2 root 2 over 3. And tangent is not going to be 1/3 either. Tangent, I'm a mess. Tangent is going to be opposite over adjacent. So that one is 1 over 2 root 2. That one comes out to square root of 2 over 4. And here's the other 3. Okay, here are the correct answers. I promise these are right this time. So again, we just flip them over. Secant, you do need to rationalize. Now here's something I want to show you. Think smarter, not harder. When we go to flip over the tangent, if I flipped over the rationalized form, I'd have to rationalize it again, right? But if I flip over the unrationalized form, which is what I did here, this is over 1, then I don't need to rationalize. They're both equal to each other, so it doesn't matter which one you do. So that's how we want to do that. Okay. Complements, little bit of vocabulary. In geometry, you learned about complementary angles. Remember, complementary angles, or angles who are complements, add up to 90 degrees, or pi halves, and we'll get to that later. Any pair of functions where f of theta is equal to g of 90 minus theta, meaning the complement, those are called cofunctions. Now, you don't really have to understand that with f and g, because here's the identities. We're going to tell you which ones are cofunctions. So these ones pair up differently. Sine and cosine are cofunctions. Tangent and cotangent are cofunctions. And secant and cosecant are cofunctions. So this time they go together with the name. The sines go together, the tangents go together, the secants go together, okay? So pi halves, pi over 2, is also equal to 90 degrees. So we can practice with that also. Pi halves is the measure of an angle in radians, and we'll be talking about that next week, exactly what radians are. So just kind of hold that thought for now. So if I want to find a cofunction that has the same value, the sine of 72 degrees, the cofunction of sine is cosine of 90 minus 72 degrees. So we get cosine of 18 degrees. Now, really important, don't forget the degrees, because as I just hinted to, there's another way to measure angles. So you have to know the units, which is degrees, so that we know that that's how we're working. Now, cosecant of pi third. Since we see that that's a fraction of pi, we know we're doing radians, even though we don't really know what a radian is just yet. Cosecant and secant are cofunctions. So the cofunction here would be the secant of, instead of 90 degrees, we're going to use pi halves. So we'll say pi over 2 minus pi over 3. Now you will need a common denominator with these. So I'm going to multiply by 3 over 3, 2 over 2. That gets us a denominator of 6. So that'll be the secant of 3 pi over 6 minus 2 pi over 6, which is just secant of pi over 6. You could put either of these in your calculator, like on part A. You could do the sine of 72 degrees, and you could do the cosine of 18 degrees, and the answer would be the same. All right, last thing is looking at some applications here. Here's a last little bit of vocabulary. Angle of elevation and angle of depression. This is measured from your eyeball. So when you're looking, like here's your eyeball, Here's your, okay, so that's where you're looking. I don't know. Here's your smile. There's your face, okay? So your eyeball has a line of sight that extends horizontally. This is like a zoomed in shot of this guy's face right here. Your eyeball has a horizontal line of sight. If you look up from your horizontal line of sight, that's an angle of elevation. If you turn your eyes downward from your line of sight, that's called the angle of depression, okay? So that's how we want to kind of measure this. That's a zoomed in version of what we're looking at, that person standing on a building there. So when we apply these, number 6 says, sighting the top of a building, a surveyor measured the angle of elevation to be 22 degrees. The transit is 5 feet above the ground and 300 feet from the building. Find the building's height. Now the transit, if you've ever seen these around town before, the transit is these little yellow tripods. That's what he's got down here, is this little yellow tripod measuring. So that's where the person is looking. So this is the line of sight horizontally from the transit, and then this angle right here is our 22-degree angle, okay? So let's sketch the triangle that we have here out to the side a little bit to get some of that picture out of the way. So they told us he's 300 feet from the building. So that's the horizontal distance on the bottom. And the angle of elevation, which is this right here, is 25. We want to know how tall the building is. So A is part of the height of the building, but remember right here, we also have the 5 feet for the transit. So we'll add that in at the end. Now, how could I solve for A? Well, we need to look at the sides we have. We have this side and this side. This side is the opposite side, and this side is the adjacent side. If we think of our SOHCAHTOA, which one uses opposite and adjacent? That's going to be TOA, so that tells us we're going to use tangent. So we're going to say the tangent of the angle, which is known, it's 25 degrees, equals opposite, which is A, over adjacent, which is 300. Okay, now we want to treat this like a proportion. You may remember this from geometry, and cross multiply here. So we get A is equal to 300 times the tangent of 25 degrees. Just like we did with logs, we want to wait until the very last step to plug anything into our calculator. Now, when you plug this into the calculator, you have to make sure you're in degree mode. Your graphing calculators default to radian mode. So you can go to mode, which is next to second, and where you see it highlighted on radian, you need to change it to degree. And I'll show you how to do that on my calculator once I get the answer here. 300 tangent 25 degrees. Whoops. 300 tangent 25 is 139 point, it didn't say how to round, so let's do to the tenths, 9. That's the height of the building from the line of sight, but then remember we need to add 5 to that, so the building is going to be 144.9 feet. That's our answer there, okay? Let me show you on here. Here's your calculator. When you go to mode, which is, whoops, that's second. Go to mode. The fourth one down says radian, arrow over, and highlight degree. Then when you type this into your calculator, you're going to say 300 tangent. You see we've got right above the numbers is sine, cosine, and tangent. So we're going to click tangent of 25 and then hit enter, and that's how we get that number there. Okay. All right. This video is getting long, so I am going to ask you to look in the PDF document to get the answer for number 7. If we have a notes quiz, that's fair game, so make sure you look that up. And then that should be everything you need to do your math lab tonight.